talking about the area or the region between two curves. Okay, so we're going to kind of review that in example. We're going to review what we did in example 4. And then in example 5, we're going to use the calculator to assist us a little bit. Okay, eventually I will show you how to do this on the calculator. Okay, we're going to not do that today, though. We're going to ease back into this by only doing 2 examples. Okay, that's it for today. Okay, because I was supposed to do this on Friday and didn't get that far. Okay, so we're going to finish this up today. What kind of a shape is this right here? It's a parabola of some kind, right? We know it opens up. I don't know where it's shifted. It's probably got some zeros. So I'm going to just sketch, because remember, I have to know what function's on the top and what's on the bottom. Okay? It's more of to get the idea of the picture. Okay, what's this a picture of? A line. What's its y-intercept? So we know it's up here somewhere and has a slope of 2, right? So it looks like the line is most definitely on the top, right? I didn't do a very good picture. Okay? At some point, they're going to cross. So the first thing I need to do, there were 2 things that we did. We know we've got to do the top function minus the bottom function. So when I go to set up my integral, which function was on the top? F or G? G is on the top. The line's on the top, right? And we should know enough about algebra and graphing to figure out what's on the top and what's on the bottom. Okay? So I'm going to do the top minus the bottom, which is this x squared plus 2x plus 1 dx. But I have to figure out my limits. So think about what we did before break. I want you to go back and look at example 3. So flip back to example 3, wherever that's at. What did we do with the sine and the cosine in example 3? No, look at example 3. What did we do with the sine and the cosine? In order to get pi over 4 and 5 pi over 4, what did we do?
We left that where they were equal to each other.
Yeah, we put them where they're equal to each other, right? So we're going to do that same thing here, right? Because intersections are where the 2 functions are equal to each other. So in order to figure out your limits, we're going to set these 2 things equal to each other. So x squared plus 2x plus 1 equals 2x plus 5. So I'm going to solve that for x. All right, what are we going to do with the 2x to move it over? Subtract it. So what's 2x minus 2x? 0. It goes away. So instead of bringing the 5 to the right, I'm going to take the 1 to the... bringing the 5 to the left, I'm going to take the 1 to the right. So when I subtract the 1 over, what do we get? 4. Good. How do we undo the square? What do we have to put in front? Plus or minus. So x equals plus or minus what? 2. So my lower limit's got to be -2. My upper limit's got to be +2. All right. That looks ugly. I would simplify my algebra before I go in and actually try to do the problem. So let's go ahead and distribute that negative in. So that, and I'm not going to write a whole nother line just to do that. I'm going to go negative, negative, negative. Do we all agree with that? Did I write it down right? Yeah. Making sure I'm doing it right. Okay, so let's look at our like terms here. Negative x squared is going to stay negative x squared. What's 2x minus 2x? 0. They're going to cancel, right? And then I've got 5 minus 1 is going to be what? That looks much nicer to integrate, right? Than it did before. Technically, you're supposed to put parentheses. I sometimes don't do them. All right, what do we get when we integrate the negative x squared? Negative x cubed over 3. What do we get when we integrate 4? 4x. Good. From -2 to 2. It's a definite integral. We haven't done a lot of definite integrals, but this entire chapter, it's all going to be definite integrals. Okay? They saved them for here. All right, we're going to plug in our 2 to begin with, top minus bottom, right? So what is 2 cubed? 8 over 3. The negative comes from the original problem. 4 times 2 is what? 8, good. Minus, and I put a parentheses, because whatever you do here, you have to distribute. I'm going to write that negative down. What's negative 2 cubed? negative 8, it looks weird right now, over 3. And then 2 times, negative 2 times 4 is what? Negative 8. All right, let's look at that one. I'm going to do a bunch of stuff in one line here. That double negative is going to go what? Positive. So now it's down to arithmetic and a bunch of fractions. All right, what do I have to do with that negative sign? So I'm now going to rechange that to negative and put this back to positive. And then kind of the trick I showed you is I try to do my like terms here, and then I'll do any equivalent fraction work that I need to deal with, okay? So what is negative 8/3 and negative 8/3? Negative 16 over 3, and then 8 plus 8 is 16. All right, if I've got to go into thirds, let's see, 16 is how many thirds? 48 good thirds. 16 times, or negative 16 and positive 48 is 32 thirds. There is no need to go to a mixed number. In fact, if you do go to a mixed number and you make a mistake, you lose the point. Okay, so you don't want to go to a mixed number. Okay. Hopefully the new part is this top, right? Top minus bottom. Okay, other than that, everything else is old and arithmetic. All right, we're going to do one more. We're going to use the calculator to help us on this one, okay? So what I want you to do is I want you to put one of these put this one into the first one, F1, and put this one into F2. This one turns out to be your blue one. This one turns out to be your red one is what we're looking at. So everybody graph it. Once you've got it graphed, go ahead and calculate your zeros, okay? I think mine's already done. So let's see if I go to my scratch pad here. So the first one should look like that, and that's my blue one. Not your zeros, sorry, your intersection points. Once you get that one done, there's the red one. Okay, and then once you've done that, we're going to use the calculator to help us, okay? So once you've got that done, the next thing you're going to do is you're going to go to your menu, analyze graph, and grab your intersection, and I want you to calculate your 3 intersection points. You're going to probably need to, I zoomed my graph a little bit, I grabbed the axes in order so I could see all 3 intersection points, okay? So I'm going to give you a minute, finish graphing, and calculate the 3 intersection points, and then sketch this into your notes. Okay, and make sure you don't need the y values, you just need the x values for your intersection points. We could do that by hand, but it's the first day back, right? We don't need to do everything by hand. Okay, make sure you've sketched the picture into your notes. The nice thing about the Inspires is they have the color, so it's very easy to say which one's on the top and which one's on the bottom. Oops. So the problem we run into here is that sometimes we want the area of both this region and this region. Okay, but sometimes the blue graph is on the top and sometimes the red graph is on the top. So what that means is that we're going to have to integrate them separately. Okay, So we're going to integrate in one section for those intersection points and then integrate in this other section. Okay, so let's see if we can set up our integral. On the AP test, they're very likely to give you something like this. They like that where they have you have to add them up. But you won't, usually it's not on the calculator, they'll give you the picture. Okay, and you have to read your intersection points out of the picture if you don't calculate them. All right, what's my first x value that I'm starting at here at this point? -2. Good, so that's my lower limit. What's my upper limit on this particular region? What's that x value right here at this point? 0. So -2 to 0. All right, in this first region, which graph is on the top? The blue graph or the red graph? The blue. So I'm going to start by doing my blue as my top minus my bottom. What's my bottom? Yeah, the -x squared plus 2x this time dx. And then we're going to add it to the other region. Yeah, it's going to be long and ugly. Okay, we're going to make it less ugly here in a minute. What is the lower limit on that region where the red one's on the top? Where does it start? Still starts at 0. Where does it end? Where's this x value right there on that point? 2. Good. Now, the red graph is on the top. The blue graph is on the bottom. So now I have to do the red one first. Minus the blue one, which was 3x cubed minus x squared minus 10x dx. Okay. Let's do as little work as possible, right? What do we need to do with these negative signs to begin with? Yeah, we got to distribute. So I'm going to kind of write over the top. So it's going to turn to a plus and a minus. This one's going to go minus, plus, plus. Okay, let's combine like terms before we get too far here. See if that helps the nastiness of this. Let's see. X cubed is going to stay x cubed. So 3x cubed. What happens with x squared and x squared? They cancel. Good. What's -10x and -2x? dx. Plus, from 0 to 2. All right, let's see. We have a -3x cubed this time. -x squared, positive x squared. What's going to happen? They cancel. Okay. And then 2x plus 10x is 12x dx. So they're similar, but not quite. There's some sign differences. All right, let's integrate it. Okay, and let's see how many integration. We're going to do some of the simplification in our heads, so we don't have to write so much. So what is 3x cubed when you integrate it? 3x to the what? 4th over 4. Good. All right, let's think about this 12x. I'm going to do some work over here. So when I integrate -12x, I get -12x squared over what? What's that going to reduce to? There we go. I'm going to do that all in one line of work, so I don't have to write it a million times. Especially when they get long and ugly like this. Okay, try to do some more of that simplification in my head. If you can't, that's okay. Write the line of work. All right, this is going to be almost the same, except the signs are going to be opposite, right? So this is going to be plus -3x to the 4th over 4 plus 6x, because when we integrate, oh, sorry, I lost a square, didn't I? Should have a squared on there. And it's going to go from 0 to 2. Okay. Remember when the 0 is on the top, it is very, very important that you use it. Okay? Because it will throw all your signs off if you don't. When I plug 0 into this thing, what do I get out of it? But you have to write down 0 minus. So you don't lose, because your sign will get messed up if you don't. Okay? All right. Let's see if we can do arithmetic in our head. What's -2 to the 4th? What are we getting? Heard somebody say it. 16. What's 16 times 3? 48 divided by 4 is 12. Okay, now we're plugging in a negative 2. What's negative 2 squared? 4 times negative 6. Good. Looking a lot better than it did, right? Remember, we're doing a lot of the arithmetic kind of in our head. All right, let's try this one. So plus, we've got to put a 2 in. We just said 2 to the 4th is 16. Times 3 is 48, but it's going to be negative 48. Divided by 4 would be negative 12. Good. All right, and then let's see. 2 squared is? 4 times 6 is? 24 again. And then does this 0 really going to matter, the one on the bottom? No, it's not going to affect signs or anything goofy. When it's on the bottom, we can kind of ignore it. But if all else fails, it's good to write it down so we know at least it was there. Okay, one extra little thing that we got to worry about here is we got another sign change, right? Because we've got a distribution. So let's distribute that in. So that would be negative positive, right? So let's see. I've got negative 12 plus 24 minus 12 plus 24. Don't these guys cancel that? So what's my answer? 24. They're not going to be short, okay? They're going to be a little bit on the ugly side, and that's okay. All right. I'm going to pull it off of that one, and I want to put up the other PowerPoint so you guys get the exact same assignment, guaranteed a 0 period here.